K.Manjanna, Associate Professor, Department of Electronics, ADB First Aid College, Harapanahally. Now, this is for BSc 6th semester, paper 7, Microcontroller and Interfacing. Already I explained in the last class ADC, Analog to Digital Converter. Now let's go for DAC, Digital to Analog Converter. Reverse the process. Already you know the analog. What is the meaning of analog? Analog is a continuous set of values over a given range, whereas digital is a discrete set of values over a given range. For example, sinusoidal waveform is an analog, square wave is a digital. Now in that case we have converted from analog input to digital output. So we considered in the last class ICC 0808, that is in ADC. It has 8 analog input channels and 8 digital outputs. Corresponding ABC are the 3 address lines. Therefore 3 means 2 to the power of 3 is 8. Therefore the particular input analog channel is selected and it gives the output. So now again in a 8051 microcontroller interfacing DAC, digital to analog converter. So now here digital signals. Now here microcontrollers are used in variety of applications, like for measuring and control of physical quantity like temperature, pressure, speed, distance, etc. In these systems microcontroller generates output which is in digital form, but the controlling system requires analog signals as they don't accept digital data, thus making it necessary to use DAC, which converts digital data into equivalent analog voltage. So therefore DAC, which converts digital data into analog in output voltage. So digital to analog converter is a device used to convert digital pulses to analog signals. So now in this figure already you know the figure of 0808. This is a circuit diagram of DAC, digital to analog converter. So this is actually 8051 microcontroller. Now here I consider the port 1. There are 4 ports in 8051. Among 4 I consider here P1 means port 1. So port 1 consists of 8 bits from P10 to P17. 8. These are the digital. Again connected to 0808, this is a DAC, digital to analog converter IC, connected to D0 to D7. Therefore the 8 digital data. So these digital data inputs are fed to here this IC. It converts from digital data into analog signals. Therefore here VCC and V reference plus are connected together, 5 volts, and this ground and V reference minus are connected together. So therefore here is a read and write pins. Now here it take output from this pin. It is connected to an op-amp, operational amplifier. There is a one feedback register. The input is a digital. This is converted into an analog current. This current is passed through the inverting input, but its input impedance of the op-amp is infinite. Therefore none of the current flows through in an op-amp. Almost all current flows through in a feedback register. So therefore it converted from current to voltage, because V0 is equal to I0 into this resistance. Therefore this voltage is appears. So it converts current to voltage. Again after conversion of DAC, it produces a current, then it is given to op-amp circuit. It produces an current to output voltage. So this is the diagram of conversion from digital to analog converter. Now you go for this interfacing of this device. In the DAC 0808, the digital inputs are converted to current. Already I explained. By connecting this register to the I output pin, we converted the result to voltage, from current to voltage. The total current provided by the I output pin is a function of the binary numbers at the D0 to D7. These are the 8 inputs data, digital, then converted into an analog current. Again, it is this current, analog current is converted into analog voltage, means current to voltage converter, that op amp is considered. Now DAC 0808 and the reference current IF and also you see. So where D0 is the LSB, D7 is the MSB. Least significant bit D0, D7 is the most significant bit for the input, and I reference is the input current and must be applied to pin number 14 of this 0808 IC. So now if you take a formula, this is the actual formula, convert from digital to analog output. Now what is the expression? V0 is equal to V reference. Now here I consider an R to R ladder network for this connection here, DAC. So V0 is equal to V reference, D0 by 2, D1 by 4, D2 by 8, D3 by 16, then D4 by 32, D5 by 64, D6 128 and D7 by 256. Here I considered there are 8 digital inputs, therefore here D0 by 2, because 8 means 2 power 8 is 256, that is 2, 4, 8, 16, 32, 64, 128, 256. So already you know the reference voltage, V reference is 10 volt. For example, the data is given 00H. 00 means H means hexadecimal, 00. So each hexadecimal number can be expressed into a group of 4 bits. So therefore 0 can be expressed 0000. Again one more 0 is there, 0000. Total 8 zeros because it is an hexadecimal number. So all data is given is 0 means 0 by something is 0. 0 into 10 volt, 0. Therefore V0 is equal to 0 volt. V0 is 0 volt because the given data is 00 means all data inputs are 00. Therefore the corresponding output is 0. If you consider another example, the data is 80. 80 can be written, 0 can be converted to 4 bits, that is 000. 8 means 1000. Therefore 10000000. V reference already you know the 10 volt. So therefore V0 again substitute V10 is equal to V0 is equal to V reference is already given, we considered 10 volt. Then according to this formula I can substitute only 1 by 2 and the remainings are 00 because 80 is given, last most significant bit is 1. So therefore 1 by 2, 0 by 4, like this. Totally the 7 bits are 0, only 1 by 2 is the highest bit. So this is a 0, therefore 10 into 1 by 2 means 2 5s are 10. Therefore V0 is equal to 10 volt. This is the conversion method of D to A converter and interfacing to this Intel 8051 microcontroller. Now let's go for another is keyboard. Interfacing 8051 with the keyboard. You know, you are familiar with the keyboard in a computer or your any row, that is it consists of rows and columns. Now keyboards are organized in a matrix of rows and columns. The CPU processes both rows and columns through ports, means there are 4 ports. According to that we have connected to the particular rows and columns of the keyboard. So with the 2 8-bit we consider here among 4 2 8-bit ports. So therefore it is 8 cross 8 matrix of keys can be connected to the controller, microcontroller. So when a key is pressed, that particular rows and columns are shorted. Whenever any key is pressed, that respective rows and columns are shorted and the remaining rows and columns are opened. So therefore here when any key is pressed, a row and column make a contact, otherwise there is no connection. Then when key is now in a microcontroller, programs are stored in EPROM. EPROM, you know the meaning of EPROM. It stands for Erasable Programmable Read-Only Memory. It scans the keys continuously. So this EPROM is taken here for scan the keys. In the following figure, you know the figure, it is a 4 cross 4 matrix. Here 4 cross 4. This is columns 1, 2, 3, 4 and rows are 1, 2, 3, 4. 4 rows and 4 columns. So therefore here 4 bits. Port, we have considered port 0, it is 4 bits, and port 1 again P1, it is 4 bits, D0, D1, D2, D3. Here rows D0, D1, D2, D3. 4 cross 4. So therefore we have connected the respective resistance. It is connected to VCC. So therefore here this is a keyboard 4 cross 4 matrix. I consider here the keyboards are organized in a matrix. Already you know this matrix form. So therefore the CPU processes both rows and columns through ports. So 2 8-bit ports and 8 cross 8. We can also consider 4 cross 4 matrix connected to 2 ports. Rows are connected to output ports and columns are connected to an input ports. So this is the procedure of connecting the keyboard interface with the 8051 microcontroller. This completes the interfacing devices about DAC and also keyboard. Okay, thank you.